Welcome everyone. Thank you so much for coming to our session in which we are going to tell you how to build your big data solution with big objects and Async SOQL, two features that Salesforce has just rolled out. My name is Alba Rivas. I work at Salesforce. I'm architecture lead of supply chain management product area, and this is my email and my Twitter handle in case that you want to contact me later. I'm also a Salesforce MVP and the South Spain developer group leader.
Good morning, everyone. I'm Agustina Garcia. I work as principal software engineer at Salesforce. I'm also Salesforce MVP, and you can find my information in case that you want to contact me later. Salesforce is the #1 cloud ERP, and for a FDC customer, using Salesforce is a no-brainer because we seamlessly connect their front office activities with their back office. We have different products like financial management, product automation, and some other. We are more than 700 employees, and our headquarters is here in San Francisco, but we also have offices in Harrogate, UK, and in Granada, Spain, where Alba and myself are based. You can also find us today here because we are under recruiting, so come to visit us at booth number 324. And this is the agenda. We will start with a quick introduction about big data, and via use case, we will explain these two new features, big objects and Async SOQL. Finally, you will have some takeaways. You selected a session that's name includes the word big data. But what does this mean? In order to explain it and to understand it, we need to think about the current needs that the IT sector is having. Every single day, the number of customers increase, and also the data that we need to store related to these customers. But it's not only the fact that we have to store huge amount of data, we need to keep it longer. And that's exactly what we need for big data. We need to create tools in order to analyze this huge amount of data in order to get the important information that is useful for us. That's the meaning of big data. At the end, a definition could be that it consists of storing extremely large data sets that may be analyzed in order to reveal patterns and trends that probably it's related to human behavior and interactions.
So what better way to explain this than with a fairly real use case? Agustina and me, for the purpose of this presentation, have created a fake company called Alhambra Developers. As a company that creates software, we have a story custom object in which we store all the definition of the functionalities that we are going to deliver. And we, as employees, usually perform code reviews of these stories in order to assure good quality of the code that we merge. As you can see, per the age of the glasses, we started doing code reviews a long time ago. And now our organization is completely full of code review records. We need to do something. We need a kind of archiving solution.
I have the solution. Maybe we can use external objects and connect our Salesforce organization with the external system, and there store all the information that we want to release from our organization.
Well, Agustina, I think that could be a good solution, but then you will have to pay the storage in the external system, and you will have to build your own integration within Salesforce. Why don't we try a different solution? For example, we could use big objects, which already live in your organization, and at least we'll only have to pay Salesforce.
It sounds interesting. Tell me more about big objects, Alba.
Okay, so big objects is a feature that has been made generally available by Witcher 18, so you can start already using it. Relational databases start to break down at millions of records. For that reason, Salesforce has created a brand new infrastructure to support big objects. This infrastructure is built with proven database technologies, as for example, Hadoop, HBase, Apache Phoenix, or Apache Pig. But although big objects live there, you can still create relationships to them. You can still create them with Apex, read them with SOQL with some limitations, read them or create them with any of the APIs that you are used to work with in Salesforce, and also set up CRUD and FLS for big objects. So what are really big objects? It's a new type of object that we can define in the organization, which lives in that highly scalable database, which API name ends in __b. And it's there to support large data volumes. But the good news is that big objects won't count towards the storage limits of the organization. Isn't that fantastic, Agustina?
Yeah, you made my day, Alba.
Salesforce has already started using big objects. There are some standard big objects currently in your organization. For example, Field History Archive is a big object, and also login event from event monitoring. But also, you can start creating your own custom big objects. However, not all the field types are going to be available for you. You will be able to create text fields, number fields, date time fields, and lookup fields. But if you create a lookup field in a big object, you are going to be able to create it to a standard object or a custom object, but never to a big object, at least not yet. So in our use case, we want to store code review custom objects. For that, we are going to create a code review history big object. But how can we do that? We cannot go to the setup menu and create them. That's not available for now. But we can use the metadata API. The way of doing it would be creating a file called code review history __b.object, like this one, for example. Include there all the information that you want to deploy of your big object, as for example, the fields that it's going to have, etc., and include it in your package XML as a custom object. It's a good idea to deploy a permission set at the same time, because by default, the big object is not going to be visible to the users. And you have to think carefully about which fields do you want to include in your big object before deploying, because for now, you won't be able to change the big object or add a field in the big object once it's deployed. So let's see a demo of this. Here, I have defined a big object called code review history 4, with some fields, some indexes. We will talk about indexes later. And I have a package XML in which I've included the metadata type custom object. So if I click on Save, I have this organization, this Mailbasement project connected with my organization. So now we can go to the Setup menu. And although I cannot create big objects in the Setup menu, I will be able to see them. So here I have my code review history 4 that I have just created. And you can see here the fields and the indexes that the big object has. So coming back to our presentation, we have created our code review history big object in the organization, but now we want to start creating records of the big object. How can we do that? Well, you are not going to be available to create a tab and start creating records there. A standard UI is not available yet, or I don't know if it's going to be in the future. But we have several options. So first of all, we could use Async SOQL, but Agustina will talk more about Async SOQL later. We could use also any of the APIs that you are used to work with, as the REST API, SOAP API, or Bulk API. So for example, you could have a CSV with the definition of your big object records that you want to create, and load this CSV through Workbench, Data Loader, etc. But there is a third way from which you can create big objects. You can use Apex. This code is going to look familiar to you because you can create big objects in the same way or with the same syntax that you create custom objects. The only difference is that standard YAML operations are not going to be allowed. You have to use database.insertImmediate. Then you will be able to examine the result of the operation because this method returns the result to you. It's important to know that these kind of operations are not transactional because we are really storing records in a different database, not the normal Oracle database that Salesforce uses behind the scenes. So if, for example, something fails in the transaction, the normal rollback that you do with the ML operations won't work in this case. And how to delete big object records? Well, simply you can't. For now, you cannot delete big object records. However, you can open a case with Salesforce support, and they will help you. What about if I want to query records? Because we have said that big objects are not available through the standard UI, but maybe we can create a Lightning component on a Visualforce page in which we can show these records. Well, one way of doing this would be with Async SOQL, but again, Agustina will talk about this later. We could use SOQL with some restrictions, and to explain the restrictions, first I have to talk about indexes. From API 40, it's compulsory that you define an index when you are going to deploy a big object on your organization. And this index is going to be the primary key or the unique identifier of the records in that highly scalable database. This index can be compound, up to 5 fields, and is going to be useful to update records. So when I was talking about creating big object records, I always talk about insert, but update is also possible. For example, in our code review history big object, we have defined an index built by employee, story, and code review date. This means that the combination of these 3 fields is going to be the unique identifier of the records in my organization. So if I perform a database.insertImmediate for a combination of index fields that already exist in the organization, really an update is going to be done. So the database.insertImmediate acts really as an upset operation. And this index is needed in order to be able to filter and order by in normal SOQL. In SOQL over custom objects, you don't need to define an index or anything in order to filter by or order by, but in this case, you have to. So in this case, we will be able, with this index, to filter by employee or employee and story, or employee and story and code review date, but always in that order. So this is an example query that we could do in SOQL and that will work. Bear in mind that here I can bring related information from the custom objects that I have related. So in our code review history big object, we had 2 lookups, one to employee and the other one to a story, and here I'm bringing related information. And also think carefully about the filtering necessities that you are going to have in SOQL for big objects before deploying, because in the same way that you cannot add fields once the object has been deployed, you cannot change the index. So you have to think carefully about that. So let's see a demo of this. This is our organization in which we have some stories, some employees, some code reviews, and we want to show the code review history records that we have already archived. As the standard UI is not available, we have decided to create a Lightning component. This Lightning component is simply a table in which we are bringing the information of the records that we have in the organization, and also we have a section that will allow us to add new code review history records. So here, for example, I'm going to add a code review done by reviewer 6 to story 5, and here I'm going to see this is the first session at Reinforce. I'm going to copy this. So I click on Add. This Lightning component behind the scenes is adding this code review history record. And if I look for the text that I have just added, we can see that it's there. How have we implemented this? It's very simple. We have a Lightning component, which is just building a table with some Lightning layouts, but the important thing to note is that on initialization, we are calling a method in the client-side controller called load code reviews. This method is this one here, and in the client-side controller, we are simply calling the server-side controller and loading the result into a variable that we will iterate later in the component. And if we take a look at the method in the server-side controller, we can see here that this is just the code from the example that we saw before. Very simple. What about the part in which we are adding new code review history records? Well, what we have on the screen is a button in which we are calling the add code review method on the client-side controller. And again, this is calling just the server and then refreshing the view to update the records that are shown in the Lightning component. If we take a look at this method, again, this is the example that we saw in the slides. So it's very simple to do it this way. If you are still in Classic, there's no problem at all because you can create a Visualforce page using the Apex and SOQL as we have seen for the Lightning component. The only thing that you have to bear in mind is that as a standard UI is not available for big objects, you will have to create a custom controller. You cannot use the standard controller.
Okay, Alba, I understand big objects, I really like it. But what about with those fields that custom object has and big object doesn't support, like checkboxes? And even more important, I have many master detail relationships. What's happened with them?
Well, don't worry, Agustina, because we have been working very hard for our archiving solution, and we have some workarounds.
Great.
So, for example, if you have a checkbox field in your custom object that you want to store in a big object, what you could do is to create a formula field that converts the checkbox into a text field, and then just archive or copy the content of that text formula field into the target big object into a text field. Or we could do exactly the same with a number field. Have a formula number field and copy the resulting number into the target big object into a number field. What about pick list? Exactly the same. You can create a formula text field with the pick list values, and once you have the text, you can store that in a field. And if you have master details, don't worry at all, because you can just copy the ID from the master detail custom object field to a lookup field into the big object.
Okay.
And remember at the beginning of the presentation when I said that you cannot create lookups to big objects. Imagine that now we want to extend our archiving solution and we want to create another big object in which we want to include a lookup to the code review history big object. So what we could do is to create fields on that second big object that reference the big object index fields. So in our case, we had two lookups and a datetime, so we would need to create those fields into the target big object and just populate them, because remember, the index is the unique identifier of the big object in the organization. We have seen many differences between big objects and subjects, but I want to highlight some of them. So for example, you have to bear in mind that triggers are not available for big objects. Also that you won't be able to set up sharing for big objects, although you can set up CRUD and FLS. And also you have to bear in mind that search, reports, and dashboards is not available for big objects, and I don't think it's going to be. But alternatively, you can use Wave. And Agustina, tell me more about Async SOQL.
Yeah, let's go back to our use case, the archiving solution. So as we were saying at the beginning, we have a custom object code review records, and also we have code review history big object records. And we need to pass the information from the custom one to big object ones in order to release some storage and leave the organization without so many data. And how can we do it? Thinking about the explanation that Alba just made, we can think that we can create an asynchronous process, for example, that help us to read big custom object records. Maybe with query more, we can handle large amount of data. And with the database.insert immediate, we can create big object records. Maybe that's enough for our use case. But what about if we are talking about a real big data? Async SOQL is the solution. Remember that this feature is part general available by winter 18, but there is part of the functionality that is still in pilot. So maybe something that I mentioned today here doesn't go live at the end when the whole functionality is released. So what is Async SOQL? Actually, Async SOQL is a feature that helps us to run SOQL queries in the background so that we can handle millions or even billions of records, and after a period of time, we can get the result without hitting overloads or timeout limitations. This feature is implemented as RESTful API.
Wait, then do I have to do a REST API call?
Yes.
And do I have to specify a body in JSON format?
Exactly.
And you say there are no limitations.
Well, keep in mind that you cannot run more than Async SOQL at a time, but there is no limitation of the number of executions per day. Let's start talking about the type of object that we can use with Async SOQL. For that, let us start with this information. Async SOQL is going to read and create or update records in a single call. However, delete is not available. So by the time, when I was saying before that we need to release some storage in the organization, that part, remove records, should be done with a different technology. But let's back to the objects. So we can read and create standard objects. We can read and create custom objects. We can read standard objects and create custom, and on the other way around. And with big objects, the same, from big objects to big objects, from big to standard and custom objects, and from them to big objects. But what is general available and what is in pilot? If we want to read big objects and create a standard or custom records, that's fine, it's general available. However, if we try to read a standard or custom object records and create any of them, a standard, custom, or big, that is still in pilot. Keep in mind. Okay, so let us start explaining how Async SOQL works with a really simple use case, not the archiving solution one. We have a custom object, vendors, and we want to move from accounts to vendors. Right now, the way to do it is with this piece of code. We do a SOQL query against account, store the information in a list of accounts, and via a loop, we can iterate over every single account and create vendors. Simple. With Async SOQL, we will do it in this way. Maybe something that you had in mind, okay, I have to do an HTTP call, we need to pass to create a body in JSON format with a query, maybe that's difficult. No, not at all. At the end, the JSON is several key values of several pair of key and values, where the first one is the query. And you can see that the value is the query the same way that we do, the same way that we show in the previous slide, just copy-paste. The second key is the operation. What are we going to do? Are we going to insert a record, or are we going to upsert a record? Keep in mind primary key, because it works in the same way that Alba explained before with how to create big object with database.insert immediate. Then we need to identify the target object. Where are we going to store the information? What are we going to create? Vendors. The target field map will help us to identify from where we are going to get the information, the fields related to account, and where are we going to store this data, fields related to vendor. But you also have the possibility to map from literal Spain to a value, to a field, the country in vendor. And this is in pilot, because we are reading custom object, standard object, and we are creating custom object. So we have the body. How is the call? Like that, simple. Keep in mind your instance name, and also at the end, /async SOQL, async queries. That's the old name. It has been changed. But if we try to run this, it doesn't work because compound fields are not supported by Async SOQL yet. So I removed the compound fields, I moved to Workbench, and I run this post call. The response is similar to this one. In JSON format, we are going to get the information. The first one is the job ID. At the end, we are running an asynchronous process. There is a background job, and we need the ID in order to get, for example, the status of that, on how it's going, and so on. And this it has also provided a global variable, $job ID, that we can store, for example, as a literal in-country field if we want. Also, we have different statuses. New is the first one, but it quickly moved to running and some others. I missed one of the fields in the response. That's the message. In the case that there is any error at the beginning, when we do the post call, there is a kind of a scan reading the information that we pass in the body, and I try to identify if there is any issue there. Actually, my first try, vendor name was too short, the field, in order to store all account names. So that's why I got this error, and the post call didn't start. And I was saying that we have the job ID because this is a background job, and we can use this ID in order to get the status and so on, and the progress. Alba, how we can do it? What do you think?
Well, maybe we can go to the setup menu and go to the Apex Jobs tab, or maybe we can query the Async Apex Job table.
Actually, that's a good thought, and I was thinking the same when I saw this feature the very first time. But they are using a different object. They are not using Async Apex Job object. So we need to go and, well, we have two options. One of them is do an HTTP GET call using the job ID that we got as part of the response from the post. Then if we continue running, we move from running to complete after a period of time. The second way to do it is with a simple SOQL against this new object, background operation. There are many fields, but here, for example, I have included finish at, or the status, or timeout. But this is not the only object that has been included in this new feature. We also have background operation results. If there is any issue during the execution of the process, it's not going to stop. It's going to store the information of this error in this table, background operation results, and continue running the execution. For example, imagine that we have a target field that is required, but the source one is empty. Then we can get this error. So when your Async SOQL process finished, you can go to this table, double check what is going on, and rerun the process if it's necessary. Just keep in mind that this information keeps in this or in these objects the next 7 days. After that, it's released. And that's all. We have moved from accounts to vendor. We have the vendor name and the country and no compound fields at all. But what about if I need to stop the process? In Async Apex Job screen, you have the abort link. But what about here? Simple. We can use the job ID again, and this time do an HTTP delete call. Then the job is canceled. And let's back to our use case, the archiving solution. We are going to move from custom to big objects. At the end, it's the same as before. We are going to read code review custom object records. We are going to create code review history big object records with those fields. And the response should be similar to this one. This is in pilot. We are reading custom objects and creating big objects. But let's go to the organization and see how it works. OK, so first of all, I will go to Workbench. And we are going to double check how many records we have. OK, yeah, let's jump into SOQL. Code review history object. And I have here, where is here? The SOQL, oh no, here, sorry about that, here. We run the query. Let's click on more in order to see how many records we have. Yeah, that's enough. That's all the records. We have 351 records. Now if I go to REST Explorer, click on Post, add the async queries, open the code review, this one, paste here. It's the same one that I showed you in the slide. Click on Execute, and we have here the response. If I copy the job ID, another REST call, this time is going to be get / the job ID, and we get the status. It quickly moves from new to running. And finally, if I go to queries again, and I open background operation, I can, for example, include the name and the status, where ID is equal to my ID. And it is running. Okay, so we have seen all these examples in Workbench, but what about if I need to move this information into my code? That's pretty simple. At the end, it's an HTTP call, so the only thing that we need to do is to create the URL, pass it as a set endpoint, and also create our string in JSON format in order to pass it as the body. The only thing that we need to keep in mind, add this URL as remote site settings, otherwise the call will fail. And that's all for the archiving solution. Let's go for another use case, predictable analysis. At the end, we have many code review history records in our organization, and we would like to get some information via reports. For example, as Alba said before, reports are not available in big objects. So we need to move this information into custom objects. But which is the benefit if I move to big objects and then I move back all this information to a custom one? Instead of that, we are going to analyze these big object records and just get the important information that we need, big data definition at the end. In order to do that, we are going to just retrieve a score about the code reviews per employees. We are going to move from big objects to custom one. The body, similar. We are going to do an average of the score that every single employee do related to code review history big objects. The only thing that we can highlight here is that in the mapping, instead of using a field, we are using the alias of this average. We can use it. And this example, finally, is general available because we are reading big object records and creating custom one. The result is like that. We create code review reports. We have several records there. In Lightning Experience, we can also include a dashboard with the average of the score. And if we are not running in Lex, we can go to Classic UI, for example, and use and create our own reports related to this object and get similar information. That's all for Async SOQL. But right now, maybe you are wondering about the differences between doing async process like batch Apex or Queueable plus SOQL plus database.insert immediate versus Async SOQL. For the first one, maybe it has better performance if we have just few hundred of records. But you have to create your own error handling. Double check if there is something wrong and create your custom object with the error, for example. With Async SOQL, the performance is much better. I give it a try with that, 14.5 million of records, and I was able to archive them in 4 hours. And it was like 2 years ago, so now probably it will go faster. It provides error handling the background operation result object. Maybe it doesn't give you the best information that you need, but at least it's there. You don't have to create your own one. And finally, you don't need indexes. When you do the query and you are going to do a filter or a group by, you don't need to do it by a field that has an index. If you go for it, the performance will be even faster, better, but it's not necessary. And that's all. Takeaways. Big objects is a new type of object that doesn't count towards limitations, and it's generally available right now, so you can leave this session and start playing with that. Async SOQL allows you to run SOQL in the background without limitations. It's generally available right now, but just half, and there is another part of the functionality that is still in pilot. Finally, big objects plus Async SOQL is a new infrastructure that Salesforce provides in order to handle big data. And the last thing, it has an extra cost, obviously, but you need to double check with Salesforce about that. And for sure, it will be less than the storage that we have in our organization. Links, the documentation. You can also have a GitHub repo with every single thing that we show here. The big object records, the custom one, the Lightning components, the JSON in order to run the Async SOQL. Every single thing is there. And also our blogs, where we are talking about big object and Async SOQL. We have already some of them released, another in mind. And that's all. Thank you so much. It's time for questions.
Okay, can you go to the microphone, please?
Please. Could you go to the microphone?
Yeah.
Yes.
I wanted to ask about the intermediate. Is there any sort of partial? Is it all or nothing always?
It's all or nothing.
Yeah, he has asked about the intermediate. I'm talking because the recording, if it's all or everything or all or, sorry, partially. I'm not sure about that. I will have to check the documentation. I can get your email and tell you later. Uh-huh.
What's the cost model?
Sorry?
What is the cost model?
The cost. We don't have that information. We need to contact Salesforce. We tried, but they didn't say to us.
No.
Yeah, that guy?
Could you please talk more about the extra cost? Is it for the big object or is it for the asynchronous software?
The extra cost, he has asking about the cost of that. You have right now big objects, so you can start playing with that. Depending on the number of big objects that you have in your organization and how much you need to store in this external database that they have, you need to pay for that. So depending on the number of objects and the amount of data. And also you have to pay for Async SOQL. At the end, I think that they are going to sell like a kind of package, big objects with this amount plus Async SOQL. And that's go in one package and sell it to you. Yeah?
In the example with the Lightning component, it looks like you're using a wrapper class and handling the stringification in the code. Is that because the Lightning doesn't support the standard, the big objects through the automatic serialization?
Yeah, we use that way because there is currently a bug in Lightning components, I think, and you cannot reference directly the fields of the object in the way that you want to use it, but that's, yeah.
Yeah.
Regarding Async SOQL, you said it was one at a time only?
Yeah.
Is there kind of queuing, or do you need to take care that there's really nothing running?
Right now, till yesterday that I tried, they said to you there is one running, you have to wait. Yeah. Thank you.
You mentioned that you have to use Einstein Analytics to do reports on big objects. Are they still compatible with like the data recipes if you're using a different data set that has like custom objects and big objects?
You are talking about using Einstein Analytics for that. Mm-hmm. We don't have this information. They said to us that we can always use waves on top of big objects instead of reports because it's not available.
Yeah,
probably.
Einstein and wave analytics.
Yeah,
like the same
so
thing.
yes, you can. I think that the theory is that yes, you can go for it. You can use it where.
Thank you.
No problem. Yeah?
Yeah, he's asking if we can deploy big objects as part of a managed package, and yes, you can. You can package big objects as normal big objects. They are going to appear under the custom object metadata type.
Yeah?
Does it work with shield encrypted, platform encrypted data currently?
I think we asked that question to James.
Yeah.
I think it works, but give me your email and I will try to contact product manager and back to you. No problem. Any other question? Yeah.
You mentioned that those are background processes, right? Are they processed the same way as the package jobs?
What do you mean about the same way?
Like using a load balancer in the background.
Using what?
A load balancer in the
A
background.
load balancer.
A load balances.
We don't know.
Not sure, actually. Sorry about that. We can, the same. You can give me your email and we can ask that question and back to you.
Yeah.
My last one. You said for Async SOQL, you don't need to follow the indexes. Is this the same for big objects?
Yeah, and when we talk about indexes, it's more for creating a simple SOQL against big objects, but with Async SOQL it's not required. If you use it, performance will be better, but it's not required.
Also for big objects?
Also for big objects, yeah. Yeah, you.
Are the slides going to be available?
Yeah, just after this session, we will upload on the session link. There is a chat window. We will put it there.
And also the recording, if you want it.
Yeah.
Is it possible to query the data of big objects through the bulk APIs? Just query it all out?
Yeah, I don't think so. What you can do is to create big object records with the bulk API, but I don't think you can query them.
Do you know if there's an ETA for that?
Well, you can do it through SOQL, through Async SOQL, that's it.
That's all.
Yeah.
Yeah.
One of the use cases you mentioned was archiving data.
Yeah.
Right? And then, but if I'm doing a master detail and I'm still keeping a lookup, how can I eliminate my transactional data that's in the custom object? That's part I'm not clear on. That's what I was saying. You're saying keep the lookup to your main record, but I'm trying to archive all of that out so I don't have to keep the custom data.
Well, in that case, what you can do is to create two custom big objects, and in one of them you create the detail, in the other one you create the master, and you create the relationship between them, referencing the index that you have created for the first big object, and in that way you can store or archive both big objects, the master and the detail.
I thought you could create lookups from big object to big object.
No, you can't. You cannot. Yeah. But there is a workaround because you can create lookups to the fields that are part of the index.
Okay, I got you.
Yeah.
Here we are saying master means all the parent objects.
Yeah. Indeed, you did a test of that, right? Archiving
Yeah.
master details.
Yeah.
That's possible. We have done it.
That's all. Great. Thank you so much.
Thank you.